Hello everyone. In this video, I'm going to explain question number 7, 8, 9 from the exercise 1.5. Okay. Seventh question. If 2.3 whole power x is equal to 0.23 whole power y is equal to 1000, then find the value of 1 by x minus 1 by y. Okay, so we need to find out 1 by x minus 1 by y value. Let's take this question on my board. Okay, this is what given condition, right? From this, we need to find out 1 by x minus 1 by y value. So I am taking here separate conditions as a separate conditions. This exponential is equal to 1000 and this exponential also is equal to 1000. From this, I'm going to find out what is x and y. Then we can find out 1 by x and 1 by y. Okay, so let's see. First one. 2.3 whole power x is equal to 1000, right? So this is in an exponential form. So let's put it into the logarithmic form. So what is the logarithmic form? Base will be same in the exponential form and the logarithmic form, right? So power x is equal to log 1000. And this base will become here base to the log. Okay. Got it? Power x is equal to log 1000 to the same base, 2.3. So, but now what do we want? 1 by x, right? In our question. So, 1 by x is equal to 1 by log 1000 to the base 2.3. Okay, let's keep this aside. Now, we will take this condition. 0.23 whole power y is equal to 1000. This is like exponential form. Now we will write it in the logarithmic form. So what is there here? Power y. Y is equal to log 1000 to the same base 0.23. But in our question 1 by y is there. So 1 by y what it becomes? 1 by log 1000 to the 0.23. Okay. Now we need to find out 1 by x minus 1 by y. So let's subtract both of them is equal to 1 by log 1000 to the base 2.3 minus 1 by log 1000 to the base 0.23. Remember children, when we make the two logarithmic bases as the same, our operations will be easy. So here there is one more condition. What is that means? If log x to the base y is there, suppose. So we can write this as a 1 by log y to the base x. If you want to reverse, if you want to reciprocate this, then this base and the number will get exchanged. Just a simple. If you want to reciprocate this logarithm, if you reciprocate the logarithm, what will happen? The base and the number will get exchanged. Here also I am, here 1000 and 1000 are same. So I want to make the bases as same. So if I want to make the bases as same means let reverse it. Okay, reciprocate this. So what it becomes? Log 2.3 thousand base 1000 minus log 0.23 base 1000. So now same basis, right? Log A minus log B, isn't it? What is this formula? Log A by B. Okay. Log, we learned x by y to the base A is equal to log x to the base A minus log y to the base A. So, log 2 by 3 divided by 0.23 to the same base 1000. Now see. Now, log, I will write this numerator as a, same like decimal. Here, after the point, two decimal places are there. In the numerator, after the point, only a single decimal place is there. So, shall I write 2.30? So, if you put the 0 after the point, end of the number, so it doesn't change its value, right? How many ever zeros you want, you can put it, isn't it? It doesn't change the value. So, log, now point get cancelled, okay? Because they both have a same decimal places, we call them as a like decimals. So, 230 by 23 to the base 1000. This is simply 10 times, okay? So, log 10 to the 1000 can be written as 10 cube. So, now, log x to the power a power m, okay, x to the power m, and here a to the power n. So both the base and the number has a power. So what do we write? These powers will come in front of the log as a power rule. So we will write m by n log x to the base a. But here there is no power, right? Imagine 10 power 1 is nothing but 10. So 1 by 3. 1 by 3 log 10 to the base 10. Now one more rule we know, log a to the base a. Log any number to the same base value is simply 1. So 1 by 3 into 1 is nothing but 1 by 3 only. Okay. So this is how we can simply solve by using the logarithmic functions. Let's see the next sum. Okay. I'll simply use. Now, eighth question. 2 power x plus 1 is equal to 3 power 1 minus x. Then find the value of x. Okay. So, 2 power x plus 1. X where it is as a power. So, these are in exponential, right? So, let's apply log on both sides. Apply log on both sides. Okay. So what do we can write? Log 2 power x plus 1 is equal to log 3 power 1 minus x. Okay. So now x plus 1 to the log 2 power rule. The power comes in front of the log. 1 minus x log 3. Okay. So now distributive property we will multiply. X log 2 plus 1 times of log 2 is simply log 2 is equal to 1 time of log 3 is log 3 minus x log 3. I multiplied with each term. Okay. We need to find out x value, isn't it? We need to find out x value. So x terms on the left hand side and the other things on the right hand side. Let's move it. X log 2 and bring this plus x log 3 is equal to log 3 minus log 2. Okay. So x is common here. Take x common. Log 2 plus log 3 is equal to log 3 minus log 2. So when plus is there, so we can use the product rule. Can I write x log 2 3 is a 6, right? When we have a minus in between the both logs with the same basis, so we can use the quotient rule, log 3 by 2. We simply want to find out the value of x. So isolate the x, take the other side, log 3 by 2 divided by log 6. That's it. This is our required x value. Okay. Now let's see the 9th question from your textbook. Log 2 rational or irrational? Justify your answer. By seeing itself, we can say log 2 is a irrational. But you need to justify your answer, not simply conclude with the statement. How can we do this? Okay, let's see. What is irrational? A rational number is a number which can be written in the P by Q form. Okay. So it contains the numerator and the denominator where P and Q are the integers, two integers if you have taken P by Q form, and the Q should not be equal to 0. That is the rational number definition. Everybody knows it. But here log 2, how you are going to prove it's a irrational number? Okay. So let us assume log 2 is a rational. Let us assume log 2 is rational. Suppose I am taking it is as a rational number. Rational number. Okay. That means what? Log 2 can be expressed in the form of P by Q, right? What is this P by Q? It's a rational number where Q should not be equal to 0. And this is in the simplest form I explain. My P by Q assumption is the simplest form. That means the ordered pair of P comma Q. I mean, both have a HCF as a 1. Okay. And P and Q are two integers here. Okay. P and Q are two integers. We know that log 1 value is 0. In the properties we have learned log 1 to the any base is 0, and log 10 value, log 10 to the base 10 is 1, isn't it? Log 10 to the base 10 is 1. Okay, if no base is mentioned, it's just a 10 here. Okay, so log 10 is 1. So here log 2 we want. Log 2 is in between log 1 and 10. So 0 is less than log 2, which is less than 1. See, my log 2 value is in between this log 1 and log 10. Log 1 value is 0, log 10 value is 1. So my log 2 value obviously in between 0 and 1. That's what I have written here condition. Okay. Now, so my log 2 is how? P by Q, right? So 0 is less than P by Q less than 1. That means what? If I transpose this Q to the other side, P is simply less than Q, isn't it? Therefore, I can mention P is less than Q. Okay. Now, so 2 is equal to 10 to the power of P by Q. From the equation 1, where is the equation 1? Log 2 is equal to, let's take this is as a equation 1. From equation 1, we know that log 2 is equal to P by Q. We have a written. This is logarithmic form. What is its exponential form? Exponential form is, there is no base means we will always assume 10, right? So the base will be same for the both log and the exponent, exponential form. So here changes only the So this one can be written as 2 is equal to, the number is equal to, base will be the same, 10 to the power of p by q. This is exponential form. 2 is equal to 10 to the power of p by q. Okay. So if I transpose this q other side, what will happen? 2 power q is equal to 10 power p. Isn't it? If the denominator in the power, if you have in the denominator, if you bring the other side, it will come to the numerator. Okay. So this 10 power p, can I write it as a prime factors? 2 into 5 whole power p. Yes. That's nothing but 2 power p into 5 power p. So let's bring it, the left hand side, we have a 2 power q, right? So 2 power q divided by 2 power p is equal to 5 power p. So use here exponential laws. That implies 2 power p minus, q minus p. Q minus p is equal to 5 power p. Okay, 5 power p. Here q minus p as an integer. And not only that, 2 power, any number you take, for example, 2 square, 4, 2 cube, 8, 2 power 4, 16. So whatever the power you mention here, 2 power, you will get even always. As a p you take here, 5 power p. P is also any integer here. Whatever the power you take, what do you get with that ends with the 5 only? Right? Ends with the 5 only. So it's a odd. Now it can be seen that now it can be seen that the LHS even. LHS is even and RHS is odd. 5 power 1 is how much? 5. 5 square 25. 5 cube 125. Okay, 5 power 4 625. So whatever the power you keep as a p, any integer you keep other than the 0. So you get here odd value only. Is it even is equal to odd? No. So hence there is a contradiction in our, hence there is a contradiction and log 2 is irrational. So like this, we can justify our answer. It seems to be lengthy, but if you listen one more time, you can just, back to my video and you can listen again, understand and work out in your book. It will be very easy. Okay. So let's see the another question in this. Log 100 rational or irrational, justify your answer. It is very easy. Just 2 steps required. Log 100 is a rational or irrational. Yeah, I can say by seeing, but I'll show you. Log 100. Can I write log 100 as a log 10 square? Yes. If there is no base to this log, what do we assume? 10, right? So here we will use the power law. Log x to the power m to the base, any base. Let us take y. Then m log x to the base y. So the power comes front of the log. Log 10 to the. And one more rule here. Log a to the base a is equal to 1. So if the log A number with the same base is 1. So it's nothing but 2 into 1 is simply 2. 2 is irrational or irrational? It's a rational. Therefore, log 100 is rational. We justified. We have given a workout that's more than enough. Rational number. This is how we can solve the logarithms. Keep watching for more number of questions. Thank you.